Hello everybody. Hello, about to start. Give it a few seconds. Thank you so much everybody for coming to this talk on cognitive services. I'll talk a bit about AI, and then in the keynote yesterday, wasn't that a fantastic demonstration of the good use of AI in the AI for Humanity Action initiative? So, like any technology, there are also some risks with AI, and so we'll touch on some of those as well. But, you know, this is a 100-level session, so just an introduction to the topic. I hope you'll find it useful. I love this word, brainbow. There's a technique that neuroscientists use to dye individual neurons and axons, and they can see where effectively the wiring, and even in the case of something as small as an insect with a very small brain, they can pretty much get a circuit diagram for the brain of an insect and really get a lot of information about it. And there are other techniques as well, but this has been known for a long time. Over 100 years, people have known how neurons and brains work. And so when pioneers in artificial intelligence started to build these models, they looked at the way that the natural intelligence works. So it is truly an artificial version of natural intelligence. And this is back in the 1950s, using an old IBM mainframe with, I call these valves, some of you call them vacuum tubes, very old technology, and they would build this device called a perceptron. It actually ended up getting a hardware implementation as well. And it's a single layer neural network. They have a grid of photocells, and they're trying to identify letters. And so there are various inputs, and then there are some weighting factors, and then there's a training algorithm. So this is machine learning, very early machine learning, training it to identify particular letters that are presented as input. And on the face of it, you know, this was revolutionary. Everybody got really excited about it, poured money into it, and did it work? Not really. It turns out to be a much more complicated problem than it appears to be, and so it kind of, all the funding dried up, and everybody thought AI was a failure. So here we are in 2018, and guess what? AI is the next big thing again. So what's happened is we started with this really highly inflated expectations of what could be achieved with AI, and then there's this dip in funding, or pretty much obliteration, which researchers in the field often refer to as the first AI winter. And then 2 decades later, another whole generation later, the whole thing happened again, this time with more of an emphasis on expert systems. So I remember this, I was involved in this sort of revolution, and expert systems were going to be the big thing, and then that didn't really pan out because I guess a lot of experts weren't too keen in going through the tedious process of codifying all their knowledge with a reward of losing their job at the end of it potentially. So that didn't really work out, and so we got the second AI winter. And now we're in this new boom. This is based on deep learning. We've sort of gone back to the machine learning that was originally around in the 1950s and gone back to those sort of techniques, except much more sophisticated, and that's sort of where we are now. Now, you might be wondering, will this just fade away again as it has done before, and is it cyclical? So I don't think it is, because the models that we're using now are, although they're fundamentally the same, they're much more sophisticated and much more powerful. We have multi-layer neural networks, and this is a hugely simplified diagram, but the inputs and the outputs are connected by a hidden layer, several hidden layers. In fact, in a lot of the models that we're going to see in cognitive services, they can be 50 plus, even 100 plus of these hidden layers. And there are all kinds of complex interconnections. There might be connections that jump over layers, groups of elements are joined together, all kinds of complexity. That's the skill of the data scientist to come up with this model that's going to work. Well, one of the criticisms is that this hidden layer is you don't really know what's going on. So there's no easy way of finding out what the AI system is how it's working. So it's a bit like a brain. You can understand how the neurons work, but it doesn't tell you what somebody is thinking. So that's one of the problems, is we don't really always know what's going on in here, and it's kind of empirical and it works, but we don't know why. We'll come to that later and see why that's an issue. So what's changed really is fundamentally the techniques are the same, but we have much more power, computational power to throw at it. So the computers are still metal boxes with electronics inside, except inside, instead of having valves or vacuum tubes, we've got transistors, so we've got 10 orders of magnitude more power at our disposal. Plus we've got the cloud. So I can say I want 1,000 of these computers available to me for the next 10 minutes while I train my AI model and produce the output. So gives us a huge amount of power, so it's really around scale and also the data. So because we have the internet, we can access a huge amount of training data that we can use in order to train these models. So what's the result? Does it work? Well, this is where we were about, so this is, my axis is wrong, I'm sorry, this is 2011, so that's only a few years ago, earlier this century. Remember that's 2011, 2012, 2013, 2014. At that stage, we're and these are on particular domains, so it's speech recognition, image classification. This is not general artificial intelligence, it's not strong AI, but it's solving these particular problems. 50% error rates is in the realm of being utterly useless, of no practical use at all. But now, here we are in 2017, 2018, it's dropped, the error rate has dropped below the magic 5% mark, which is this dotted line here. So once you get below 5%, that's the level of human error. Now it becomes interesting. As for an AI system to work, for machine learning to work, it doesn't have to be 100% accurate, it just has to be about as accurate or better than a human being. And then all of these problems, which are very tedious, studying video frame by frame and all these kinds of things, can be put through an AI system, and it's as good as having people looking at it, and nobody wants to do that kind of thing. So this completely changes the game. Once you get to this level of accuracy, it's a complete game changer. So let's see how this works in practice. It's not much use to us if it's difficult to use. So is it something that we can use without having to become an expert on artificial intelligence and machine learning? So what I'm going to look at, I'll just put my spectacles on, here is I'm going to look at classifying butterflies. I know that's not really a typical business problem, but it just applies. It could be products or looking for defects or events or something like that. But it's an interesting one because it's quite a tricky one. The butterflies look pretty similar unless you're an entomologist. Does anybody know which butterfly this is, out of interest? Go on. So, no, it is not a monarch. No, that's a good guess. So I'm going to compare that with a monarch and a red admiral, which all look quite similar. That's actually a painted lady butterfly, which you get all over the world. So it's not. We get them in Europe. You get them in North America. You get them in the UK, where I come from, and so we'll compare them. No, so it should be a difficult test for the algorithm to be able to tell the difference between those. So let me just switch. And so if you go to cognitive services, and you can Google for it, or it's not a very easy URL to remember, but it's easy enough to find, you'll find that there are a number of pre-built models. Okay, so you don't have to train them. They're generally pre-built models that are ready to use for problems. So we look at that. You've got speech, search, knowledge, language. Probably vision is the one that we want to look at. So we'll go to vision. And when I look down vision, I've got one here called computer vision. So that looks interesting, doesn't it? So you might have seen this before. It will take an image. This has all been trained with vast amounts of data, and it can do things like it can say, okay, yeah, that's somebody, that's a train at a station, you know, I've seen a station, and you can feed it another image. Here's a dude on a skateboard, and it says a young man riding a skateboard. So it works well. You know, this is general, it's not specific. So let's see what happens if we pass this one of these butterfly images. So let's try it with this one. So this is a peacock butterfly. And we say it says a small insect on a white background. Not quite what we were looking for. You know, if I send it another one, let's try this picture that we saw at the start, the painted lady. It's a close-up of a purple flower. Okay, so this is the wrong model to use for what we're trying to do. So you might think, I've heard of something called the Microsoft Cognitive Toolkit. Surely that's it, that's much more general. Let's have a look at that. So I'll go over to Microsoft Cognitive Toolkit. Again, it's easiest to just Google for this. And if we scroll down here, we can see there's quite a lot of detailed information. There's a model gallery, that sounds promising. And if I navigate to that, one of the first things that comes up is this one that somebody's written called AlexNet. This is actually a neural network model that won the 2012 Image Lab classification challenge. So you know, it should be pretty good. But then you look at this and oh right, okay, there's Python scripts that are calling some APIs. There's a link here. Let me follow that, and it takes you to what you then realize is a scientific paper. So okay, it's an academic paper. I'm not ready to do another PhD right now. I just want to classify butterflies. So this is really a tool for data scientists. What we want is something in between that's something we can apply quickly without having to learn about it. Now, you know, if you're going to go back to school, there's a tool that Microsoft now have called AI School. There's a booth about 50 yards in that direction, which I'd strongly recommend you go and talk to them. And this will go through all these things that I've been talking about in much more detail, and you can learn about it. It's a great resource. So I would recommend going there. I think it's booth number 228, if I remember correctly. It's not far from here. I can just about see it from where I'm standing. And if you looked at that, you'd probably find that there's a thing called custom vision. So I've got it open here, but if we go back to that page I was at for vision originally, it's down here, custom vision. And that is a model that's been pre-built, but it hasn't been trained. It's one that we can train. So that's the right level. That's where we want to be, is we want to train a model. So what I can do there is I've already logged into this. You can get a free trial for this. And you can do things like object detection. There was an example of that in a talk yesterday, so I won't cover that one. But let's just create a new project, and we'll call it Butterfly Spotter. And I'm going to say classification. I'm going to say multi-class. So I'm going to tag each of these images. So this is what's called supervised learning, which you're telling it what the tags are. There's another approach you can use, which is unsupervised learning, where we let the algorithm figure out what the classes are. That's probably going to give us things like all the red butterflies and all the blue butterflies or something. We want something more specific, so we're going to use supervised learning. I'm going to leave that domain as general and create a project. And it says, looks as though you haven't got any images there. So I need some images that I can use to train the model. Now, that's really easy to do. I can go over to Bing and do an image search for monarch butterfly. Now, on the whole, you'll get mainly images of monarch butterflies of about the right size, very convenient to train the model. Eventually, you'll find you get odd things like a caterpillar or somebody's abstract art picture of a monarch butterfly or something like that. So you do have to kind of go through and check that they're all suitable, but it's pretty easy to do. It depends what field you're doing. In some cases, you can just let Bing do the searching, and it's sufficient. So I've already copied down some of those images and put them into a folder, so I can now add them to the model I've created. So let's start by taking all the monarch butterflies. So I'm going to select all of those. And now I'm going to add the tag. So the tag is monarch. And then I'm going to upload them. And it uploads those files into Azure, and that's that one done. So I've now got one set of images. I'm going to add some more. So I'm going to add the images for the painted lady, which, if you remember, was the one that we originally had on the screen. So now I have to tag those as painted lady. And then and it's detected a duplicate, and one of them went wrong, but it's okay, we have enough. And then let's add one more, so we'll add the Red Admiral. And so I have to label that as well, so that's Red Admiral. I don't know how much time I've spent building this model and training it, but I think we're about 3 minutes in so far, so that's that one done. So now I've got a set of images that I've categorized, and so I can now need to train the classifier, and it'll look for features in who knows what it's doing. I mean, it's probably different this week to what it was last week, because the models are always being improved. But it'll look through, and it'll because I've told it which type is which, it will look for the best set of parameters that matches up. In fact, it's done quite well. Now, we cheated a little bit because they're quite nice pictures of butterflies. If you went and took a photograph of a butterfly, it'd be like sideways on, or it'd be, wouldn't be straight and things like that. So, I've made it reasonably easy by giving it some images where the butterfly pretty much fills the frame, but we could use object classification to find them if they were sort of buried away and didn't take the whole of the field. So I've trained it. I can now test the model. So I've kept some files back, some images back, just for training, for testing. So they're not part of the training data, and you can see that it's identified this one with 99.9% probability as a painted lady, and it's rejected the other two possibilities. And then if I take another one, let's look at, say, the Red Admiral, and it's identified the Red Admiral correctly. Let's try it with the Monarch. And again, it's identified correctly the monarch butterfly. Maybe it's just the color of the flower it's sitting on or something like that. Let's try a monarch with a totally different background. It still works. So that's great. Yeah, I think that's incredible for a couple of minutes work, that I've got something that can actually distinguish between these three categories of butterfly. Now, we can throw it a curveball and say, let's throw it a peacock butterfly, which we didn't include in our classification. Now it's totally confused, and slightly worryingly, it said it's 99.9% probability that it's a painted lady. So it's definitely not the other two. Well, it's partly right. So we've only trained the classifier for those three cases. So we would then have to put more types in to make a fully automated butterfly classifier. But I think it's incredible how effective that is and how well it works. Now, we can use an endpoint, so there's a REST API that we can call once we've trained the model, so we could have some application that connects to Azure and that endpoint, and just uploads an image and it'll classify it. The other things you might want to do is just very quickly show you this because it's rather interesting. You can say there's a general compact model you can use, and if I just retrain that, I did that correctly. Hang on, no, wait a minute. I didn't save it. Got to press. Oh, I did press save. Okay. Wait a minute, just a minute. Let's go back to here. Now it's done it, and now you get the option to export. So this still works. I can run a quick test and it'll work, but I can export in one of these model formats. So this is like Onyx is it's like a model description that can be used on top of other frameworks. So if you've got something that works on a mobile device or an IoT device, for example, you can export that model and use it without needing to be connected to Azure. So the power of Azure is only really needed to train the model, not to use it. Okay, so just going back to our slides, and we'll just wrap up. I think they're trying to tell me something. That's 7. That's not 7. 5. So I think that's amazing. I never would have dreamt 10 years ago that I'd be able to demonstrate a model like that can classify images, and it only take a few minutes as well to create it. So that's fantastic. I mentioned that there are some risks around artificial intelligence and machine learning, and you can read scary books like this one that talks in great detail about some of these ethical issues and some existential risks as well. So the ethical issues are, how we use these tools. So suppose we had 10,000 job applications for a programmer role, a software programmer, and we thought we were lazy. I just want to get this down to 10 candidates so I can interview them. And you might implement something in AI using machine learning, but it might learn that, we notice all our programmers are young men, they're sort of 25-year-old men, and that gets embedded into the model, and now you start just rejecting anybody who's sort of my age or who's a woman. A real recruiter wouldn't do that because they'd know that you mustn't do that, but the AI model doesn't. So there are dangers that we can build all kinds of, just talking about diversity, for example, which is a bit of there's a track on this at the conference, but it introduces some very special dangers, so we have to be extra careful and vigilant and think ahead about some of the many ethical issues that something so powerful as this can expose us to. And then there's also an existential threat, and this is a bit more sort of science fiction, but there's something called artificial superintelligence, which is, here's the problem. So we've been talking about very specific, domain-specific intelligence, but there's also general intelligence, what researchers call strong AI, which is, the machine has a general knowledge, not just something, not in a specific domain. And machine learning is improving. We're nowhere near human level for general intelligence, but one day we might be there because human intelligence isn't really increasing very much. In fact, if you've got teenage children and you see them on their social media, then you might even think that it's heading back down again. So, this may happen faster. So there will come a point, almost certainly, and people disagree about when it is, maybe in 30, 50 years. Some people say, not that far into the future where this happens, and then this is very dangerous because the AI can outthink us and it can switch itself back on. We can't just switch it off, and so a lot of people are worrying about that. On the converse side, a lot of people saying these risks have been overblown and exaggerated, particularly on Twitter, but of course they could be bots that are doing that, so you've got to be careful. They could already be getting there. No, I think there is some way away from this, but it is a significant threat. So, one day we're laughing at YouTube videos of robots falling over, and the next day it's Terminator 3 without the time travel part. So, we've got to be a little bit careful. Now, this is a bit of a cliche that every popular article about AI gives us. I don't think there would be some battle. I think we just wouldn't see it coming. So we need to think about this sort of thing now. So yes, it's here. Artificial intelligence and machine learning there. It's real this time. It's practical. It can be applied to real problems, is being applied to real problems. Joking aside, there are some ethical and existential risks around this technology, so we have to use it with some thought and start thinking about those things now. You don't have to be an expert. These tools are available to use today. That you can go and get a trial. Go and to aischools.microsoft.com and learn about it. And I will be happy to take questions. I'll stick around for a little while. I'm not sure when they kick us out of here. But thank you very much indeed. And please fill in an evaluation. That's my training data for me. So thank you very much indeed. Thank you.